The principles of technology that we've been studying so far have all dealt with motion. In this unit, we're going to take a slightly different approach. We're going to look at influences that try to control motion and even try to make things stop moving. It's virtually impossible to move something without encountering some kind of resistance. The friction of one object rubbing against another tries to slow the action. Fluids rubbing against pipes are slowed down. Electrical current is always lost from resistance in the wires. But we can also use electrical resistance to control the current in the wires. And the flow of heat is slowed by materials that are good insulators. Resistance is like a force, except it usually acts in the opposite direction of force. Resistance is most helpful when we want to control motion. For example, jumping out of an airplane would be insane without resistance. Objects fall because the force of gravity pulls them down. When resistance is introduced by a parachute, it acts against the force of gravity, slowing the object down. In other words, resistance affects the rate at which objects move. If you know how much force is involved, and you introduce just the right amount of resistance, you can effectively control that rate. To find resistance, you only need to know these two things, the force and the rate. Resistance acts against force and affects the rate, so resistance is found by dividing force by the rate. In mechanical systems, objects encounter drag force caused by the fluids they're moving through. Drag force is why so much effort is spent trying to find the best shape for a vehicle so it doesn't waste fuel. Fluids themselves encounter resistance as they rub against the walls of pipes. In this case, pressure difference acts like force to move the fluids. The resistance cuts down on the movement of the fluid or the flow rate. In a similar way, electrical resistance opposes voltage to cut down on the current or the flow of electrons passing through the wires. Thermal resistance works against temperature difference to cut down on the rate of heat flow. This helps reduce the heat loss. In each case, resistance is found by dividing force, or whatever acts like force, by a rate. So force, pressure difference, temperature difference, or voltage is divided by speed, fluid flow rate, heat flow rate, or current. A force divided by a rate. You might get the idea that because resistance opposes force, it's a problem, something that must be overcome. But this is not always the case. For example, when fluids are pumped through pipes, resistance works to slow them down. On the other hand, a valve creates resistance to control the flow of the fluids. Electrical resistance allows us to precisely control the flow of charge, and therefore do things like change the intensity of lights. Mechanical resistance can slow the motion of a vehicle, while thermal resistance is the basis of insulation, where the flow of heat is reduced and controlled. In technical operations, like a nuclear power plant, resistance can be both a friend and an enemy. Leslie Wildfong is a nuclear engineer who not only monitors resistance, but uses it to control the operation.
This is the heart of a nuclear power plant. This is a nuclear fuel pellet. In the process of turning this into electricity, we encounter a lot of resistance in many forms. We have thermal resistance, getting the heat out of the pellet to the water, which encounters fluid resistance going through the pipes. Gets to the turbine, turning the turbine, we encounter mechanical resistance. And finally, we encounter electrical resistance in transmitting the electricity off-site to the various cities. For example, the material the fuel pellet is made of is ceramic, which resists heat. The outside temperature of this bundle is about 580 degrees. The inside, or center line, is over 2,000 degrees. To get the heat out efficiently, we stack it in very thin rods in tight bundles. We transfer the heat to water and use the heat to make steam. Getting the steam from the generators to the turbine, it It has to go through valves and a lot of bends in the piping. If we make the bends too tight, the resistance is too great, and we can destroy the piping. The fluid resistance helps us in turning the turbine blades, turning the turbine along the shaft, but we encounter mechanical resistance in that the shaft is resting on metal bearings. The turbine turns the shaft of the generator, which creates the electricity, sends it to the transformer, and we increase the voltage by greater than 10 times to overcome the resistance in the lines. What we do in the control room is monitor and control the various forms of resistance in the plant. We monitor the resistance that works against us along the turbine shaft. We control the steam flow and the fluid flow in the plant. And we use resistance to control the electrical output of the generator.
Resistance is like an extra force that always appears, sometimes unexpectedly, and in places you may not think about. Can you find how resistance is being used in this concert? By the end of this unit, you should be able to point it out.